Hello. So I'm going to do a lesson on how to complete the square to change a quadratic equation that's in standard form into vertex form, as we've talked about in class. And when it's in vertex form, it's just much easier to graph. You can see the vertex right away, find the axis of symmetry from that, maybe follow the pattern or plot some quick points, and you've got your graph. I'll do a little bit of notes and then I'll do some of the homework. So yesterday we completed the square with a quadratic equation, and the coefficient of the x squared was 1. So here a is equal to 1. To complete the square, it is mandatory that this be 1. So yesterday when we did this, everything was fine because the quadratic already had its coefficient of the x squared as 1. This is a. Remember, this is a for the x squared term. This is a. So I'm going to go ahead and complete this square with a equal to 1. And the way I showed you was x squared plus 4x and move the 8 way over here to get it out of the way for now. So we can complete the square on the first two terms. This technique works. Now remember, we take the b term, the b, and we divide it by 2 and we square it. So we take 4, divide it by 2, and square it. And that's what we'll put here. So that's 4 divided by 2 is 2, squared is 4. We can't just add 4. We're going to have to also subtract 4 to keep the equation the same values. Now I can factor this. And the way we factor the perfect square trinomial, this perfect square trinomial, is take the square root of x squared, the square root of 4, look at the signs. If they're both positive, put plus, square up here, and then simplify the outside, which is plus 4. And that looks an awful lot like the vertex form. And we're done. It's very quick to see the vertex. Remember, the vertex is the opposite sign of the inside of the squared term here. So it's minus 2 for the x, and it's plus 4 for the y. There is our vertex. The axis of symmetry is equal to that x, so that's equal to x equal to negative 2. That's axis of symmetry. Just thought I'd mention that again. But today in class we looked at quadratic equations that had an a that was not 1. A is not 1 here, it's 2. So in order to use our completing the square method to get our perfect square trinomial and get our quadratic into the vertex form, we have to get rid of this 2. There's a couple ways I talked about doing it. I said most of you liked the idea, I think, of dividing everything by 2 to make this a 1 in front of x squared. That's what we want. So if we divide this by 2, we get a 1. So that means we have to divide everything by 2. So let's just do it that way. Y divided by 2 equals x squared. 8x divided by 2 is 4x. And this is minus 3. So what that does is give us a coefficient of 1. Okay. I'm going to use the method to complete the square. X squared plus 4x, rewrite with minus 3 way over here. Rewriting. Now we take half of 4 and square it. Half of 4 is 2. And we square it, and we get 4. So we add 4 and subtract 4. Then our first 3 terms are a perfect square trinomial, because we added 4. Now we'll factor. Square root of x squared is x. Square root of 4 is 2. We square it out here, plus plus. And then we simplify out here to be minus 7. Now we're almost done. We're not quite done. I need to remember that I have my 2 that was divided over here, and we want y by itself. Vertex form has y by itself. So I'll multiply. Earlier we divided everything by 2. Now I'm going to multiply everything by 2. So what does that look like? When you multiply everything by 2, it looks like this. Y equals, because those cancel, y equals 2 times the x plus 2 squared term, and then 2 times the negative 7 term. So just multiply 2 times this on the outside. That'll take care of multiplying everything on the inside by 2, because you would distribute that. And there is our vertex form. Y equals 2 times the quantity x plus 2 squared minus 14. And our vertex would be negative 2, negative 14. Very quick to see. Whoops, I'm sorry. Let's try that again. There's our vertex form. And our vertex is negative 2, negative 14. Okay, let's do another one. Now on the notes, this should say a 6. That should be a 6. Let's try that again now. So we have 3x squared plus 6x plus 3. I'd love to put this into vertex form. You know what it looks like. Y equals a times x minus h squared plus k. I'd love to put it there so I can see the vertex very quickly. But I don't have a coefficient of 1. So I can factor out a 3 or divide every term by 3. So I'm going to take y and divide it by 3, and that's going to be equal to x squared. This divided by 3 is x squared. This divided by 3 is 2x. This divided by 3 is 1. This happens to be a perfect square trinomial already, so I can just factor this right from here. But if you didn't see that, you could still use your method. And let's just do it with the method. Let's put a plus 1 all the way over here. And you'll see we're going to end up, we could have just factored it from there. But half of 2 is 1. 1 squared, so remember 2 over 2 squared. That's 1 over 1 squared. That's 1 squared, which is 1. So add 1, subtract 1. Half of 2 is 1, squared is 1. And then I can factor this perfect square trinomial that we created by adding that 1. X plus 1 squared minus 1 plus 1 is just plus 0 on the outside. So we could have just factored straight from here, but that's okay. And we have y over 3 on the other side. We're not done yet. Y has to be all by itself, so let's multiply everything by 3. Y equals, and then 3 times x plus 1 squared, and there's no k to multiply it by. And there is our vertex form. What is our vertex from that? Well, inside the squared we have a plus 1, so that's minus 1 for our h. And our k on the outside is 0, so 0. This parent graph was moved to the left one, so that gives us a negative 1 for x. And it was not moved up or down, so it's at 0 for y. Now the next example has a negative in front of the x squared, which means it has a negative 1. We want 1. So we are going to divide everything by negative 1, and that will make it possible for us to get a 1 in front of x squared. I'm going to do it the long way to show you what it kind of looks like if you factor it out. So y equals, well, let's take negative 1 out from the first term, and that's going to be x squared now. And negative 1 from the second term, that's going to be plus 6x. And negative 1 from the last term is going to make this a minus 7. It's as if I divided everything by negative 1, because I kind of did. And then to get this negative 1 over here, I'll just divide by negative 1. So y over negative 1 equals x squared plus 6x minus 7. So factoring out the negative, the a that we don't want here, factoring out that negative 1 so that we end up with a 1 here, is one way of looking at this. Or we could just look at it like we divided everything by negative 1. Negative 1, negative 1, negative 1, negative 1. And we get y over negative 1 equals x squared, positive, plus positive 6x minus 7. Okay. Factor the perfect square trinomial. Well, we have to make it first. X squared plus 6x, and then we'll